Hello friends, welcome to our channel Mechanical Motivator. In this video, we'll be seeing thermal and dynamic problem for the forces acting on an IC engine. So this is a thermal problem combined with our dynamics. So first of all, we need to understand the few thermal concept and then we'll be going in detail with the problem. So first of all, I will be explaining what what they have asked in the question. A vertical single cylinder single acting diesel engine has a cylinder diameter 300 mm. So yeah. So cylinder diameter is 300 mm. So D is equal to 300 mm. Convert into meter. The stroke length is 500 mm. So stroke length. So capital L is the stroke length. They have given 500 mm and convert into meter. The connecting rod length 4.5 times of the crank length. Let the connecting rod length will be L, which is nothing but 4.5 times than the crank times of the crank radius. So L is equal to 4.5 R. R is the crank radius and L is the connecting rod. And the engine runs at 180 rpm. So n is equal to 180 rpm. So convert into angular velocity. So 2 pi n by 60, you will be having a value 18.85 radian per second. And another thing, okay, the mass of the reciprocating part is 280 kg. So mass of the reciprocating part they have given us mr. Mr is equal to 280 kg. Then compression ratio is 14. So compression ratio is nothing but we can write as RC, which is nothing but V1 by V2 is equal to 14. Compression ratio value. The pressure remains constant during the injection of oil for 1/10 of the stroke. So this line we'll be seeing while doing the problem. So have a note of it. The compression and expansion follows the law PV constant. PV 1.35 is equal to constant. So this is the law. So our case will be following this law. So what we need to find is we need to calculate the crank pin effort. So we need to calculate crank pin effort is nothing but FT. Then thrust on the bearings. So FB and turning moment on the crankshaft. So T torque. When the crank displacement is 45 degree from the inner dead center position during expansion stroke. So theta value they are given. So theta value they are given. And one more thing is the suction pressure, the initial pressure, suction pressure can be taken as 0.1 Newton per millimeter square. So actually what is the concept is, so this is a vertical engine and this is the piston and this is the connecting rod, this is the crank radius. So once the piston moves downwards, so here we will be having the swept volume. So this is the top dead center and this is the bottom dead center. Piston will be moving from top dead center to bottom dead center. So this volume they are calling it as swept volume. And here we will be having the clearance volume. VC is the clearance volume and VS is the swept volume. So here we will be drawing, we will be having a pressure and volume graph. So y-axis will be pressure and x-axis will be volume. So here we will be having 4-stroke. It's a diesel engine, right? So actually it's a diesel engine. So first 1 to 2 is the suction stroke, 2 to 3 is the compression, and 3 to 4 is the power stroke, and 4 to 1 is the exhaust. So these things we know clearly. So here they just plotted, this is the pressure for 0.1 and pressure 0.4 and here 4 dash. Actually here we will be determining the pressure and volume of the gases. That is at this point what pressure it will be having, like that we will be calculating. And one thing is that is we know very well that the pressure is constant. P2 is equal to P3. So this is the basic information which we need to know. So now we will be going step by step. So pressure volume PV diagram we saw previously. So I've explained what are the 4 strokes and 4 strokes which will be involving, and P1, P2, P3, P4 will be corresponding to 1, 2, 3, 4 point, and volume similarly same way. So for diesel engine, actually we already know these things. We already studied in previous videos also. So in diesel engine, what's happening is PV is equal to constant. They have given the question. So it's a constant. The injection of fuel takes place at a constant pressure, and in exhaust it's a constant volume. See the diagram. So here the volume is constant, and here the pressure is constant. So PV is equal to constant, right? So P1 V1 power 1.345 is equal to P2 V2 power 1.35. So in this, actually we know the value for P1 volume 1 and volume 2 also we know, because how means compression, I mean compression ratio they have given in the question, they have given compression ratio value. So P1 we know, so just keep P2 alone on the one side and take everything to the other side. So bring the V2 to the denominator. So V1 by V2 whole power 1.35. V1 and V1 by V2 is nothing but the compression ratio, which is nothing but 14. So once you substitute in, we will be getting the pressure 2 value 3.526 Newton per millimeter square. Swept to volume, the formula is Vs is equal to pi by 4 d square into L. So diameter you know, stroke length you know. So diameter and stroke length you know clearly. Here stroke length they are given right. So radius is nothing but half of the stroke length. Whatever stroke length we are having, radius is nothing but half of the stroke length. So substitute the values and you will be getting this swept to volume as 0.035 meter cube. And next we need to determine the VC, that is clearance volume. So compression ratio is V1 by V2. So V1 we can write as VC plus VS, and V2 we can write as clearance volume. So just so VC divided by VC will be becoming 1 and VS by VC keep as it is. So in this we know the compression ratio value V1 by V2 is 14 and Vs value we just now calculated. Vs swept to volume we just now calculated. Only Vc is the unknown. So this unknown we can easily calculate. Take the unknown to the left hand side and keep the unknown on one side and take everything to the other side. And you will be getting the value of 0.027 meter cube. Here V2 is equal to Vc. We have clearly mentioned here also. Since the injection of fuel take place at a constant pressure, as I told earlier, P2 will be equal to P3 and continues up to 1/10 of the stroke. So these lines are given in the question itself. So therefore, the volume at the end of the injection of fuel, that is V3, we need to calculate V3. So V3 is equal to Vc plus 1/10 of the stroke. So they have given in question itself. So Vc plus 1/10 of the stroke. Vc we have calculated and Vs swept to volume we know very well. Actually it's given, actually we also found in previous. So just substitute the value and get the value for V3. So here we have got the V3 value. So when the crank displacement is 45 degree, that is theta will be 45 degree from when it moves from inner dead center to outer. So during that the expansion stroke, what happens is we need to calculate the displacement value. So this is the formula for displacement. So R value we know and theta value is 45 degree and N value we know because N is nothing but L by R. So these values we know clearly. So from that just substitute all the values and get the displacement value by using simple calculation. And now what we're going to do is we just going to calculate the what is the volume in between. That is, here we need to calculate what is the volume at this 4 dash point as well as what is the pressure at this 4 dash point. P4 dash and V4 dash we need to calculate. So P4 dash is equal to, that is we know the law PV is equal to PV power 1.35 is equal to constant, right? So P3 V3 power 1.35 is equal to P4 dash V4 dash power 1.35. We want to calculate P4 dash. So keep that alone on one side and bring everything to the other side. So here we will be having V3 by V4 dash. V3 we calculated. Previously we calculated V3. And V4 dash we just now calculated. So V4 dash, for calculation V4 dash nothing but same Bc plus pi by 4 d square into x. So displacement just now we calculated. So if you substitute all the values means you will be easily getting the V4 dash value and substitute that V4 dash here. So it will be easily determining the P4 dash, the pressure at 4 dash point, 2.2 Newton per millimeter square. Now actually we want the difference of pressure on both two sides of the piston, right? So P is equal to P4 dash, which will be at maximum, minus P1, that is suction pressure. So if you subtract the 2.2 with suction pressure means you'll be getting 2.1 Newton per millimeter square. So if you convert means millimeter to meter 10 power 3. So 10 power minus 10 power minus 3. So 10 power minus 6 will be denominator. When it's go to numerator, 10 power 6. So actually why we are doing these things is we need to substitute the P value here. For that purpose we are doing. So we have got the P value. Now we can easily calculate the net load on the piston. So whatever we saw, actually we did all these things in order to substitute this P value. In order to calculate the P value, We did all this stuff. So till now it's thermal side, and now we are going back to the forces which will be acting on the reciprocating engine. So we need to calculate whatever asked in the question. So net load on the piston is FL formula. FL is equal to P into pi by 4 D square. D we know and pressure we just know calculated. So you'll be getting the value of net load on the piston. So next is inertia force on the reciprocating part. So the inertia force is nothing but mass of the reciprocating part into acceleration of the piston. So we know the formula. So substitute all the values in the formula and you will be determining the inertia force. And next we need, in question they will be asking crank pin effort. So for that crank pin effort we know the piston effort value. So for piston effort is nothing but FL net load on the piston minus FI. Since it's accelerated, the piston is moving from top dead center to bottom dead center. So it's written as M, it's written as minus, and plus we know the formula. Actually these things we clearly discussed in previous video. So no need to worry, just substitute the formula alone. So you know the value for WR is nothing but weight of the reciprocating part, and mass of the reciprocating part you know, and just multiply with gravity. And FL you know, FI you know, everything, all the values you'll be knowing. Just substitute all the values and get the piston effort value. So you would have calculated piston effort value. First thing they will be asking is crank pin effort. So FT is the crank pin effort. For this we require phi. Phi is the angle of inclination of connecting rod to the line of stroke. So sin phi is equal to sin theta by n. So here we can easily calculate. You know the value for theta and you know the value for n. So just substitute and calculate phi value. In crank pin effort, just substitute the theta and phi value. So FP value you know, just know you calculated. So substitute all the values and you'll be getting the crank pin effort. So next is thrust on the bearings. Thrust on the bearings nothing but FP. So thrust on the bearings we are having the formula theta and phi value we just now calculated, and FP value we also calculated. So substitute all the values and you will be getting the thrust on the bearings. And last is turning moment of the crankshaft. Turning moment of the crankshaft formula is FT into R. R is the crank radius and FT value just now we calculated, crank pin effort. Substitute those values and we will be getting the values directly. So once you calculated the pressure means it's very easy for us to proceed. Only thing is still calculation of pressure you will be having some difficulty. In case if you are having any doubt means just type in the comment section. Please do subscribe to my channel Mechanical Motivator and press the bell icon. Then only you will be getting all the videos which I upload. And thanks for watching this video. Have a great day.